Okay. That's the first side. Now we want to do the same on the other side. So we're going to create what is called, introduce what's called a rotate table setup. This will allow you to index it. And in this case, I'm going to say rotate it 180 degrees and select OK. So we now rotated it by 180 degrees, which means on your table, it would turn the part over by 180 degrees, right?
Right.
And then we're going to repeat the same operations. I'm going to do a copy and a paste. And now the operation is pasted right in here. Right-click and regenerate. It's going to compute your tool pattern.
Based on the model on this side, correct?
That is correct. So it's computing it based on the part and the stock material for a roughing operation. And you can always do a pause, simulate to end. Any questions, sir?
Nope.
Okay, so now that you've done your roughing from the two sides, if you want to go back and rough it from this additional side, we can rotate it to get to some of these detailed features in here, or you can go directly to a finishing process on those sides as well, because we kind of have cleaned it up and brought it to almost close to the net shape of the part, right?
Right.
So the next step is to do a finishing. We could do a finishing from this side we are already on. We could just go from a roughing process to a finishing process. I could start with like a parallel finishing operation. Go with the 1/4-inch ball mill that you're referring to. Establish your feet and speeds and clearance, and then you can also specify how do you want to cut it. By default, it's set to go along X, which is angle of cut is 0, parallel to X.
Mm-hmm.
You can go lengthwise. You can change it angle of cut to 90 degrees. You could do that. And then also you can specify if you wanted to limit it by putting in a boundary in here. I can actually select this and then create like an outline around it. So if I do not pick any geometry, the system will automatically compute it based off the part and based off the part geometry. So it's not going to. You can also simplify this in here and create an outline here. So I'm going to basically take the outline we created. So let me show you without creating a boundary how it works. You can also specify in like a Z containment. In here, how far down you want it to go on the side. I could say I only want to go past the midpoint. So that's your midpoint. Maybe go down 100 thousandths. And now I'll pick generate. So the system will automatically compute the toolpath based off the part geometry. So all the finishing operation uses the part information that you have right there. So you can see it's also going in and cleaning up these areas as well, right? So if you wanted to not cut into those areas, that's where the containment comes into play. So you could use a containment boundary in here to basically create like a little area to limit your toolpaths. And I can specify a region in here. So if you're going to be using a 1/4-inch tool, so what I'm going to do is use this as my boundary in here to contain the toolpath too. So the toolpaths will be automatically contained to this area, as you see it, right?
Mm-hmm.
And you can also tighten up your step overs. I just left it at 25% step over, but you can set it up to go much tighter. So this could be like a pre-finishing operation. So there's your 3-axis parallel finishing operation on your indexer. And all we are doing here is on a live demonstration for you, so there was nothing prepped up. And you can see how easy it is to work with.
Mm-hmm.
And you can always do a pause, go simulate to end. So we would repeat the same process for the other side. Do a rotate table setup. we'll put it back to 0 degrees from 180. So rotate it back to 0. And then we want to repeat this parallel finishing operation in here. Right click, regenerate. Hit the tool path. And the beauty of this is you are able to see the simulation from all the sides, right? What's being machined. And you'll see that if there are any areas that needs to be refinished, you could always go back and do it. Now you can see that there's a little seam you're getting because you're not cutting far enough on the side, right?
Right.
So if I had cut past maybe by the tool radius on the sides, then it would have probably cleaned this out. So you can go back and make changes, make edits to the operation, and then regenerate your tool path. Is this how you typically machine this part?
Yes.
Okay. All right. Now let's go ahead and work on these features in here, right? There are the 90 and the 270 degree orientations. So if you want to go ahead and take a look at it, if you look at it from the right side view, you will notice that there are these areas that needs to be machined in here, right?
Right.
So what we can do is we can create a nice little boundary in here in Rhino. I'm going to just basically trace around these boundary areas. I'm just using a freeform curve command in Rhino to go around creating a boundary in here. So I just defined a boundary there, as you noticed it. And you can see right here, the boundary is created. The one we created is right in here. I'm going to rotate the coordinate system again. So use rotate table setup. And I'm going to be rotating it by 90 degrees, which goes to the other side, or I can do 270. Then repeat this parallel finishing operation. And for the region, I'm going to pick this boundary we just created in here. And you can specify any Z containment if you need to. Or I'm going to skip the Z containment and generate the tool path. So this would produce a tool path. And as you can see, it's able to machine that undercut, which you weren't able to do it from the top or from the bottom. Now, if you wanted to do a roughing operation, you could have done that as the first operation before we did the finishing operation in here. Okay? Now, the last step is to do the same over on the other side. We could flip this over to the other side. So we can make a copy of the setup and paste it. And then I'm going to change the angle from 270 to 90 degrees. I can either use the same boundary that we have here, or I can switch the view from right to left. I can change the view, say set view to left, and I can draw another boundary in here for just programming this area. So I'm just using basic drawing tools in Rhino to create these. I'll pick this as my boundary right here. And I can specify any Z containment if I'd like to. And then generate it. So this would now create a tool path. So we did one on the left.